In this lesson, you will use a recursive formula to list terms in a sequence, and we'll write recursive formulas for arithmetic and geometric sequences. A recursive formula is each term is formulated from one or more previous terms. And we have been working with explicit formulas, so what's the difference between the two? Well, I have two different formulas for the same sequence. The explicit formula, what we're used to doing is just plugging in our n values. So the first term would be n is 1, so a sub 1 is equal to 2 times 1. A sub 2 is equal to 2 times 2. A sub 3 is equal to 2 times 3. A sub 4 is equal to 2 times 4, so on and so forth. In a recursive formula, the a sub 1 term is given to you automatically. You know a sub 1 is 2. And then to find a sub 2, you use this formula, and you would say a sub 2 is equal to a sub 2 minus 1 plus 2. Well, a sub 2 minus 1 is a sub 1. And we know a sub 1. It told us it was 2. So 2 plus 2 is 4. If I wanted to find the next term, which is a sub 3, I would say, okay, what's a sub 3 minus 1? That would be a sub 2, right? And do we know what a sub 2 is? Yeah, it's right here. It's 4. So that'd be 4 plus 2, which is 6. And we could continue on, and we would find the terms. But do you see in the recursive how you have to use the previous term to find the next one? Whereas in the explicit, you could just plug in the values and find it. Recursive, you have to use what's behind it. So let's use a recursive formula to find the first 5 terms in this sequence. We know a sub 1 is 7, so we know our first term is 7. We don't have to worry about that. Now a sub 2 is going to be equal to 3 times a sub 2 minus 1, which would be a sub 1, minus 12. A sub 1 is this value that we've been told, so it's 3 times 7 minus 12, which is 21 minus 12, which is 9. Now a sub 3 is going to be 3 times a sub 3 minus 1, which would be a sub 2. And a sub 2, we know that, we just found it, is 9. So this is 3 times 9 minus 12. So 9 times 3, which is 27, minus 12, which is 15. We have to find the first 5 terms. So what we're going to do is continue on by plugging these values in, but if you can find a pattern to get to the next term, you are allowed to do that. You don't have to show your work for every single one. A sub 4, 3 times a sub 3 minus 12. A sub 3 is 15, so 3 times 15 minus 12. That would be 45 minus 12, and 45 minus 12 is 33. A sub 5 is 3 times a sub 4 minus 12, and we know a sub 4 now is 33, so 3 times 33 minus 12, and that's going to be 99 minus 12, and 99 minus 12 is 87. So the first 5 terms in this sequence, we found them by using a recursive formula, which is using the previous term to find the next term. So try the example in your notes. Now here are the steps for writing recursive formulas. First of all, you're going to have to decide if the formula is arithmetic or geometric. Remember, arithmetic is a common difference, geometric is a common ratio. Here you're finding the common difference D, here you're finding the common ratio R. Then you can write your recursive formula, and here they are. Geometric always looks like this, always. It is a sub n, r times a sub n minus 1, where r is the common ratio. It always looks like this. Arithmetic always looks like this. A sub n minus 1 plus d, where d is the common difference. So if you know the common ratio, you're just going to multiply it by the previous terms. If you know the common difference, you're going to add it to or subtract it from the previous terms. And then you always have to state what the first term is, a sub 1, and the domain for n. N can never be greater than less than 2, because you can't have a 0 term. You always have to have a sub 1 to start it. So that's why we just have to say what n is. And I'd like you to remember your explicit formulas, because we're going to need those for today. So remember the geometric sequence explicit formula is what we've been learning this week. A sub n is equal to a sub 1 times r to the n minus 1. And the arithmetic sequence comes from a couple chapters back. A sub n is equal to a sub 1 plus, and then we have in parentheses n minus 1 times d. So we multiply that common difference times the n minus 1 and then solve it from there. So in example 2, you're going to write a recursive formula for the sequence. Let's follow the steps. Step 1, is it geometric or arithmetic? So let's look at this and see. Well, from here to here, it looks like I'm subtracting 4. Here, subtracting 4, here, subtracting 4. I'm thinking this is a common difference of minus 4. You can look at it and see if you can multiply anything to see if it matches. So I'm going to use the sequence that's in your notes for the arithmetic recursive, where a sub n is equal to a sub n minus 1, and instead of saying plus negative 4, I'm just going to say minus 4. And then I have to state two things. I have to say what a sub 1 is, so a sub 1 is 17, and then I have to state what n cannot be. So n has to be greater than 2, because it has to fit in here. It can be equal to 2, I guess, so greater than or equal to 2, but it can't be a 1, 1 minus 1 would be 0, and we can't have a 0 term, so it has to be greater than or equal to 2. So we have our first term, we have our recursive, and we have our domain. So that is a good example for this sequence. So let's try this one together, and then I'll have you do a couple in your notes. Now, I look at this one and I see that that's times 4 right away. I know that I'm multiplying by 4. Is 24 times 4 96? Yes, it is. And so on and so forth. So I already know that this is a common ratio of 4. I'm multiplying by 4 each time. So now I'm going to look at my notes for the geometric recursive formula. And what I'm going to do is say a sub n is equal to that common ratio 4, and then I'm going to multiply that times a to the n minus 1. And then I have to state two things. The first term is 6, so I say a sub 1 is equal to 6. And I can't go bigger, n has to be greater than 2. I can't go less than 2 because then that would be a 0 term. So this is everything I need for this geometric sequence. I've got my first term, my recursive for geometric, and my domain. So you try the examples in your notes. Now we can take one situation and write it in both different forms. So this is a real-life situation where n is going to be the number of customers, and clients of a shuttle service get picked up from the homes and driven to premium outlet stores for shopping, kind of like Uber or Lyft or something like that. And the total cost of the service depends on how many customers there are. So if this n is the number of customers, one customer is 25, 2 is 35, 3 is 45, so on and so forth, you can see that what we're doing each time is we're adding 10. So I know that this is a common difference of 10, and this is going to be considered an arithmetic sequence. So to write a recursive formula for this sequence, I know a sub 1 is 25. I know my n has to be greater than or equal to 2. And my a sub n is going to be a sub n minus 1 plus 10. And I got this formula from using my notes. So you just look in your notes to find where the arithmetic sequence is. Now we're going to look in our notes for the explicit formula. And that was back a couple slides ago. Remember that explicit formula for an arithmetic. This is an arithmetic sequence. A sub n is equal to a sub 1 plus n minus 1 times d. So we're going to have to plug some values in here. So the values that we would plug in would be our a sub 1, which we know in this case is 25. We do know that we have our d value is 10. So if I had to, I'll just rewrite this times 10. The first thing I'll do is to distribute this. So I have 25 is equal to, or sorry, not equal to, 25 plus 10n minus 10. Can I combine anything here? Yes, I can combine my 25 and my minus 10. So a sub n would be equal to 10n plus 15. And this is the explicit formula for my arithmetic sequence, and this here is my recursive formula for the arithmetic sequence. So you can write any sequence both ways, in both different forms. So how could I go then from one form to the other? Well, this is an explicit, and I want to know the recursive. So what you might have to do, if this is my explicit formula, you might have to, well, you have to think of two things. Is this arithmetic or geometric? Well, you know if I have this adding here that this is going to be an arithmetic, so I'm going to have to figure out what my D is, my common difference. And one thing that I recommend you could do is just plug in, because it's an explicit formula, just plug in a 1, and that would be 6 times 1, which is 6 plus 3, so your first term is going to be 9. A 2 would be 6 times 2 is 12, plus 3, 15. 3, 18, plus 3, 21. And now I have enough to kind of see what that common difference would be. And if you look, your common difference here, you're adding 6 each time. And if you can figure out where you can get that common difference from that formula, you could use that too. So if I know my common difference is 6, then, and I know my first term right here is 9, I have everything I need for my recursive. So a sub n is equal to a sub n minus 1 plus 6, where a sub 1 is 9, and n has to be greater than or equal to 2. So I just wrote my recursive from the explicit that was there. I can go the other way too. Here is my recursive formula, and I can try to find the explicit from that. So I know my first term is 120, and then I'm going to take that times 0.8 to find my next term, which I'm going to go ahead and just do. I'll find a couple terms just so we can use them. So 120 times 0.8. Next would be 96. Next would be 76.8. So I know my common ratio is 0.8. If you remember the geometric explicit, which we've been working with this week, a sub n has to be equal to, I have to know that common ratio. And what I'm going to do then is figure out what my a sub 1 is, which is 120. And I write a sub 1, which is 120, times my common ratio, in this case it's 0.8, to the n minus 1. That's what our geometric explicit formula is from our notes. A sub 1 times r to the n minus 1. If you wanted to clean it up a little bit, if you don't like that dot in between since we're working with a decimal, you could do this, and that cleans it up just a little bit so you don't have that decimal to get combined with, or confused with that dot there. That just cleans it up a little bit. All right, try the example in your notes.